And start.
Good morning, students. Up to last lecture, we have studied some basic concept that we have to use in this chapter. Okay, we have start chapter laws of motion. Okay, in that we are up to studied force is a one important quantity that we require, important thing that we require to move any object. If we apply force on some hot object, then motion of that object is takes place. Means simply we can move that object from one place to another place. Okay, so now we have to see what is actually motion. Actually we know motion is relative concept. Okay, which concept? Relative concept. And if we see definition of motion, then it is tells us that if the position of an object is changing with respect to its surrounding. Okay, what? Position of an object changing with respect to its surrounding, then it is said to be in its motion. It is said to be in motion. Okay, so what happened here? Position of object should have to always change with respect to surrounding. Then and then we can say that object is in motion. Otherwise, what happen if the position of an object is not changes surrounding according to the or with respect to the surrounding, then that object we can call it not in motion or in rest position. Okay, so what? Object's position should be changed time to time with respect to surrounding. Okay, suppose we are standing here and in front of us one road is there. Okay, then one bicycle is traveling from the road. Then if one motorcycle come and go away from us. Okay, so actually what happened, we are initially at stationary position, we just observe the road. One vehicle is very far away from us that come near to us and then go away from us. Actually what happened, position of that vehicle is changes. First it is very far away, then it is came near to us, and then again go far away from us. Okay, so continuously what happened with respect to surrounding, with respect to us, position of that object is continuously changed. Then such a case is called as a motion. So what happened, if the position of an object is changed with respect to its surrounding, then it's called as then it is said to be in motion. Then that object should be in motion. And if the position of an object is not changes with the surrounding, then we call that object is in at rest position. Suppose the one stone. Okay, we are observing full day a one stone. Its position is fixed throughout the day. Position is not changed with respect to us. Okay, we can't observe some changes in position of that stone. Then such an object where position of object is not changed, then we can call that object is in rest position. Now we have to consider some example where motion is happen or not. Okay, in that first example is the flight of a bird. A somewhat bird is a flying in a sky, then at that time what happened, its position changes with respect to us continuously or not? Yes, when a bird is fly at that time what happened, continuously its position get changes, so it is in motion. Now second is a stationary train. If a train is stationary, okay, it is in front of us but it is stationary, it is not moving, then its position is not changes with respect to surrounding, then that object is called as a stationary object. And third is leaves flying through air. If is one of the leaf cut and fly through air, then at that time also what happen, if the position is continuously changes, so this leaf is also in motion. Okay, So one important thing for motion that also we have to remember, that's only we can call motion if and if position of an object changes with respect to surrounding, then that object we can call is in motion. Otherwise, if the position of an object is not changed, then that objects are called as in rest position. Okay, so clear definition of this motion. Okay, so next topic we have to see, that is displacement and distance. Okay, so actually distance and displacement are two different concepts that are not similar, their meanings are different. Don't be confused in that. Okay, just remember actually meaning of distance and displacement. First of all, look at what is distance. Distance is what? Simply the length of actual path. Whatever the path we covered, that all path is called as a distance. Okay, distance is what? Length of actual path. And now second is displacement. Displacement is what? The minimum distance between start and end point is simply called as a displacement. Okay, so if every day we are going from home to school and again came school to home, then our displacement is how much? 0. Because displacement is what? Distance between initial point and final point. Minimum distance between initial and final point. Okay, so that's called as a displacement. Look at very basic difference between distance and displacement. Distance is what? Total length of a path, how much we cover, that is nothing but the total distance. And displacement is what? The minimum distance between start and end point. Okay, look at, remember this line in front of these two, distance and displacement. Don't be confused in that. Now look at, we have to see one example given in our textbook. Okay, so Sheetal and Prashant goes to the school and they show here the path followed by them. Okay, this is their home. Okay, this is Sangeeta's house and this is school. Okay, so this Sheetal and Prashant, this is the Sheetal and Prashant's home. From here they have to go to school. Okay, now what happened? What Sheetal do? Sheetal first go towards his friend Sangeeta's house. Okay, he first went to Sangeeta's house, then Sangeeta and Sheetal together go to the school here. Okay, now Sangeeta and Sheetal house distance is 500 meter. 500 meter. School is 1200 meter away from Sangeeta's house. Okay, what happened here? First, Sheetal went towards Sangeeta's house, then both combinedly together go to school. So, for Sheetal first cover this much distance, means 500 meter, and again from here to here 1200 meter. Okay, means Sheetal has travelled total distance of Sheetal has to travel this 500 meter plus again this 1200 meter, means she has to travel 1700 meter distance. Okay, and his brother Prashant also start from same house, but he follow minimum distance path. Okay, minimum nearest shortest path. Now he go from this diagonal path. Okay, so if we apply here Pythagoras theorem, because we can form one right angle triangle over here as like this. Okay, so by applying Pythagoras theorem over here, we can find out this distance. Okay, so this distance is how much? 1300 meters. Okay, so Prashant has to go 1300 meters only, but this Sheetal has to travel this 500 plus this 1200 meter, total 1700 meter distance. Now question is that who has to cover more distance and who has shortest displacement. Both displacement, look at here, distance is what? Actual path cover. Distance is what? Actual path cover, length of actual path, and displacement is what? Distance between starting point and ending point. Okay, both are start from here and end here. Okay, it is clear. So this is the displacement. How much? 1300 meter, but actual path cover is not same. Okay, look at here, for Prashant this is the path followed by Prashant, so this is his displacement. How much? 1300 meter. So distance is how much? 1300 meter is actual distance covered by the Prashant. But what about Sheetal? He covered 500 meter plus 1200, so 1700 meter distance. So one thing we have to remember here, displacement and distance are two different things. They are not same. Look at here, displacement is same. Both displacement is same because Prashant is also goes to school and Sangeeta is also goes to school, and their minimum distance between school and home is how much? 1300 meter. But if they change path, okay, then their distance will not be same. Here you will find that Sheetal's distance always higher than as compared to the Prashant distance, because it first went to Sangeeta's house and then goes to school, so he has to cover more distance as compared to Prashant. Okay, so from this example we understood that distance and displacement are two not one things, they are different. Okay, simply distance is what? Length of actual path covered, and displacement is what? Minimum distance between start and end point. Okay, now we have to see again some example of distance and displacement, how they are different from each other. Now consider this is a one straight line track. Okay, one car is start from here and length of this track is 360 meter. What happened? This car is start from point A, goes towards point B and again come on point A. Okay, what happened? Start from A, goes toward B and again came on point A. Okay, so what about it? Distance and displacement. Now we studied, we see definition. Distance is what? Total path covered. Now the length of this path is how much? 360 meter. So distance will be total path covered. First it go towards B, means 360 meter. Again it come back from B to A, 360 meter. Okay, so it will be 720 meters. That is the actual distance covered by this car on this track. Okay, so distance is what? Total actual path covered by that object, that is the 720 meters. Now what is about the displacement? So displacement is the minimum distance between initial point and final point. So what happened here? First car start from here, goes toward point B and again come on point A. So the initially start from here and again come on this point. So what is the actual minimum distance between these 2 points is how much? 0. So its displacement will be 0 because that car again come on the same point. Okay, so remember that what happened? Distance is what? Total actual path cover, and displacement is what? Distance between, minimum distance between initial and final points. Okay, so another one example we have to see, that of the circle. Okay, so here one circular ground. Okay, and we are going jogging for this ground. Okay, it has radius of 100 meter. So we start from point A, we complete one circle and again come on point A. Okay, so what about our distance and displacement? Okay, so we know total length of this circumference is how much? 2 pi r. Okay, 2 into pi 3.14 into r is how much? 100 meter. So the total length of this circular circumference of this circle is how much? 628 meters. Okay, means in one round we will cover distance how much? 628 meter. So what about the distance? Distance is what? Actual path covered, that is how much? 628 meter. Okay, 628 meter. And second is what? What's about its displacement? Displacement is what? Minimum distance between start point and end point. Here start point is A and end point is also A, means there is no distance of separation between initial and final point. Starting point is initial point, that is why our displacement is 0, but distance is not 0, that is 628 meter. From that, one thing we have to understood, for some motions your displacement may be 0, but your distance never 0, because distance is actual path covered and displacement is a minimum distance between 2 points, that is the initial point and final point. Okay, so we have to see next topic, speed and velocity. Okay, so before going that, we have to clear first two definitions that are we studied, that is the distance and displacement. Distance is what? Simply actual path cover, and displacement is what? Actual minimum distance between initial and final point. Okay, so these two things we have to see, speed and velocity. Okay, so simply speed is what? Speed is the total distance covered divided by time required to cover that distance. So total distance upon total time. So distance means what? I already told you, actual path covered divided by time, that will be our speed. And we know distance is measured in meters and time has a SI unit, second. So the unit of speed is meter per second. Okay, again look at speed is what? Total distance divided by time, and its units is meter per second. Next thing we have to see, velocity. Now velocity is what? Actual displacement upon time. Okay, so this is the difference between speed and velocity. It is the difference between formula of speed and velocity, that also you have to well remember. Some small differences are there. In speed we have to take total distance, we don't have to think here about displacement, but in velocity we have to take in account actual displacement, not a distance. Okay, so these two formulas you have to remember. So unit is also meter per second, because displacement again we measure in meters and time we measure in seconds. Okay, so this is the difference between velocity and speed formula. Speed is total distance upon time and velocity is displacement upon time, and both have same unit, meter per second. Okay. On numerical we solve on distance and displacement. Okay. So speed and velocity. First, the example given on page number 3 that you are also have to read. Okay. So look at that. The straight line distance between the house of Sheetal and Sangeeta is 500 meter, and the between Sangeeta's house and school is 1200 meter. Also, straight line distance between Sheetal's house and school is 1300 meter. Suppose Sheetal takes 5 minutes to reach Sangeeta's house and then 24 minutes to reach school. From there, then we have to calculate Sheetal's speed along path A, path B, and Sheetal's average speed. Okay, from that numerical. Okay, so first of all, they also gives us time. Okay, so path A means what we already see. This is Sheetal house and this is Sangeeta's house. Sheetal's house, Sangeeta's house. Their distance is 500 meter, and she takes time to cover that. That is 5 minutes. Okay, so we have to calculate here the Sheetal's speed. So Sheetal's speed will be equal to, speed is what? Distance upon time. So that will be equal to, distance is how much? 500 meters upon time is how much? 5 minutes. So it will be 100 meter per minute. 100 meter per minute. That is the Sheetal's speed, because he has to cover 500 meter distance in 5 minutes. So formula is distance upon time, 500 meters upon 5 minutes. It will be 100 meters per minute. That is the Sheetal's speed. Okay. Now from what happened? Sheetal's from Sangeeta's house, school is how much? 1200 meter distance. Okay. So what is the speed of Sheetal on this way, this path? That also we have to calculate. Okay. So from that path, she takes 24 minutes. Okay. So Sheetal's speed along this path B will be equal to distance upon time. Distance is how much? Again 1200 meter, and time taken is how much? 24 minutes. Okay, so divided by 24 minutes, so that will be equal to 50 meter per minute. 50 meter per minute is a speed of Sheetal along path B. Okay, now Sheetal's average speed is how much, that we have to see. Sheetal's average speed, that will be total distance upon total time. Total distance upon total time. Now here Sheetal start from his house. First she went to Sangeeta's house, then go to school. Means this 500 meter plus this 1200 meter. So total distance is how much? This 500 plus 1200 meters. Okay. Then the total time is also what? This 5 minutes plus this 24 minutes. So 5 plus 24 minutes. So it will be equal to your 1700 upon 29. Okay. So your answer will be 58.6 58.6 meters per minute. Okay, that is the Sheetal's average speed, and one thing is remind, that is the Sheetal's velocity. Now velocity is different concept. I again told you, that is the minimum distance between start and end point. That is how much? 1300 divided by total time. Total time is how much? This you have to add these 2 times also here. You have to solve this problem again, that present on your page number 3. Okay, so this remaining part of velocity you have to calculate. All you have to calculate. Again solve this problem. It will be better to understand you this concept, speed and velocity. Okay, so today's lecture we are studied about distance and displacement, speed and velocity, again also motion. Remaining part of this chapter we will see in tomorrow's lecture. Thank you.